Imagine this. Picture yourself in a quiet room, two ordinary bar magnets clutched in your fists. You align the north poles toward each other, inch them closer, and whoosh, there's this uncanny, invisible barrier shoving them away. It's as if the empty space between them has suddenly come alive with resistance, defying your every effort to force them together. No visible connection, no mechanical trickery, just raw, inexplicable power at play. But wait, do you really grasp what you're probing when you blurt out, "Why do magnets repel?" Spoiler, you probably don't. And until you unravel why that seemingly innocent query is riddled with flaws, every response you get from experts, books, or even this video will leave you scratching your head in frustration. Buckle up, because we're about to dismantle that question piece by piece, revealing truths that could reshape how you see the entire cosmos. If that sparks your curiosity, smash that subscribe button now so you never miss these deep dives into the mysteries of science. All right, let's jump right into the heart of it. That repulsive force you're feeling isn't some quirky sideshow of nature. It's a direct peek into the foundational fabric of everything around us. Yet, so many people tackle this topic backward. They crave a quick, relatable simile to make sense of it all. You know, the type of magnets repel, just like how oil and water don't mix. Or imagine it as two kids on a playground shoving each other away. These might sound soothing, like a warm blanket for your brain, but they're fundamentally misleading. They're not genuine insights. They're mere placeholders that prevent you from confronting the real deal. I'm going to lay out exactly why leaning on such shortcuts traps you in a cycle of bewilderment and how breaking free can lead to profound understanding. The core issue here is that magnetic repulsion does unmimic anything more basic because it is the basics. It's not layered atop simpler principles. It's the ground floor of physical reality. There simply isn't a deeper layer to excavate for comparisons. Posing the question, why do magnets repel, is akin to inquiring, why does addition work the way it does in a reality? You can't demystify mathematics by appealing to concepts more primitive than numbers. Themselves, math is the primitive foundation. Similarly, the electromagnetic force driving magnetic behavior is one of the universe's elemental laws. It's not an outgrowth of everyday things like elastic bands snapping back or palms pressing together. In fact, those everyday experiences are manifestations of electromagnetism itself. But let us suppose you've likely encountered talks of magnetic fields, looping around poles or electrons whirling like tiny tops. Don't those provide the ultimate clarification? Well, not entirely. Those elements offer superb depictions, incredibly detailed and spot-on in forecasting behaviors. They elucidate the how the force propagates through space, how its strength diminishes with distance, how we can quantify it in equations. However, the profound why, the reason this force is woven into the universe's blueprint, it all remains untouched. Mixing up description with existential explanation is a common pitfall, and until we clarify that distinction, our dialogue risks spinning in circles without progress. To illustrate, let's try a hands-on experiment you can do immediately. Place your hand on a nearby solid surface, your desk, a countertop, even the arm of your chair. Apply firm pressure downward. Notice how it halts abruptly, refusing to sink through. What's stopping it? Your knee-jerk response might be, well, duh, because the surface is solid. But hold on, that's not illuminating anything. It's merely rephrasing the observation with a different term. Solidity is the label we slap on this resistance, not the cause. Probe further, why the halt? Perhaps because the atoms composing both your hand and the surface are densely packed. That's a step forward, but let's dissect it. Atoms aren't like minuscule billiard balls crammed together impenetrably. Dive deeper into atomic structure, and you'll find something astonishing. An atom is predominantly vacant space. To visualize, upscale an atom to the dimensions of a massive sports arena. The nucleus, housing protons and neutrons, would be no larger than a marble plopped in the center field. The electrons, they'd be pinprick specks orbiting far out in the upper decks. The vast expanse in between, utter nothingness. So your hand is essentially a collection of these empty atomic stadiums, and so is the desk. Logically, they should interpenetrate effortlessly, right? Yet they don't. This realization should unsettle you a bit, hand. That's productive discomfort, the kind that sparks genuine curiosity. The true culprit is electromagnetic repulsion among electrons. Those electrons in your skin carry negative charges, as do those in the desk. Identical charges inherently push apart. When you press down, you're experiencing the cumulative effect of quadrillions of these microscopic electromagnetic nudges aggregating into what we perceive as solidity. There's no physical collision. It's all repulsion across an infinitesimal void. Now, here's the zinger that'll twist your thoughts. Why exactly do like charges repel each other? You might retort, because of the electromagnetic force. But that's tautological naming the phenomenon without unpacking it. It's equivalent to saying magnets repel due to magnetism, which explains zilch. The electromagnetic force ranks among nature's four fundamental interactions, the others being gravity, the strong nuclear force, and the weak nuclear force. It's not an effect of some prior cause. It's not reducible to more elementary components. It simply exists as a bedrock truth of our universe. And crucially, the very force barring your hand from phasing through the desk is precisely the same one causing magnets to thrust apart. Not a close cousin, not a vague parallel, the identical electromagnetic force. So, why does the desk scenario feel mundane while the magnet one baffles us? The answer lies in your personal history. From the moment you were a crawling infant, perhaps as early as 6 months old, you've interacted with solid objects incessantly. Pushing toys, grasping bottles, tumbling and impacting the floor. These encounters have etched deep neural pathways in your brain. By toddlerhood, your mind has amassed a vast database of tactile experiences, forging intuitive models of how the world behaves. Neurons have linked up to anticipate resistance upon contact, rendering it second nature. You don't ponder it. It just is. Contrast that with magnets. For most, meaningful encounters with magnetic repulsion come later, if at all, and they're less frequent. The repulsion occurs across a visible void. You can slip a sheet of paper between the poles, confirming nothing tangible bridges them. That visual cue clashes with your ingrained expectations, triggering a sense of anomaly. It demands justification because it deviates from your experiential norm. But the reality, the oddity, resides in your cognition, not the laws of physics. In the desk push, electrons never truly touch. They repel across a gap to minute 4 perception, mere angstroms wide. We dub it contact out of convenience, but it's electromagnetic force bridging a divide. Magnets amplify this to perceptible scales of few millimeters or centimeters, making the gap evident and thus disconcerting. The underlying physics remains unchanged. Only the magnitude differs. This insight is pivotal. Your unease stems from psychological conditioning, not inherent physical enigma. You're at ease with atomic scale electromagnetic repulsion because it has underpinned every physical interaction you've had since birth. Macro scale versions feel alien simply due to scarcity in your life story. That's the crux no more. No, you might pivot to advanced physics. Surely quantum mechanics demystifies why the electromagnetic force persists. Not so fast. Quantum electrodynamics, or QED, stands as science's pinnacle of precision. We've validated its forecasts to staggering accuracy measurements aligning to the 11th decimal place. It's unparalleled. Yet QED excels at computation. It equips us with formulas to predict electromagnetic behaviors with pinpoint exactness. From particle scatters to energy shifts, what it doesn't furnish is a philosophical why for the force's existence. It masterfully models the force but doesn't dissolve it into simpler tenets, as none exists below it. To drive this home, consider a parallel puzzle. Why does ice bob on water rather than sink? Surface answer. Ice's density is lower than liquid water's. Why lower? Its crystalline lattice spaces molecules farther apart. Why that lattice? Hydrogen bonds in water molecules orient specifically upon freezing. Why that orientation? Quantum mechanics governs electron distributions in H2O. Why those quantum traits? They arise from the Schrödinger equation, dictating wave functions, and the Pauli exclusion principle, barring identical electron states. Why do these principles reign? See the pattern? Each layer peels back the onion, but you're merely deferring the query. Swiftly, you reach the universe's foundational bedrock core equations and forces. There, the sincerest response is, this is what observations reveal. This is the universe's modus operandi. We encapsulate it mathematically, scrutinize via experiments, harnessed for innovations, but transcending to more fundamental explanations. Impossible as we've hit the floor. This exposes the subtle flaw in querying magnet repulsions. Why? You're not purely after data. You're seeking solace. You yearn to tether the unfamiliar to the known, quelling disorientation with a tidy tale culminating in comfortable territory. Yet, magnets repel via electromagnetism, which persists as an intrinsic cosmic attribute. No epic narrative, no cascading causes just, empirical facts and math. I get it, that might not quench your thirst for closure. You crave elaboration, but the universe operates indifferent to human desires. It is unyieldingly itself. What truly irks me about this inquiry is framing magnets as eccentric outliers amid a sea of normality. Invert that lens. Normality is suffused with electromagnetism. Scrutinize any process, chemical reactions, electromagnetic bonds shuffling electrons between atoms, enabling everything from digestion to combustion, light mirroring off surfaces. Photons, electromagnetic waves interacting with electron clouds vision à vue, electromagnetic spectra stimulating retinal cells, translating wavelengths into color perception, computing devices, currents of electrons steered by electromagnetic fields through silicon pathways. Electromagnetism isn't a niche curiosity confined to fridge magnets or compasses. It's ubiquitous, the preeminent force shaping your existence. Gravity, feeble by comparison, dwarfed by a factor of 10 to the 36th power, irrelevant for molecular affairs, strong and weak nuclear forces, sequestered within nuclei, their influence wanes beyond atomic confines. All tangible phenomena's electromagnetism's domain, the repulsion between magnets mirrors the cohesion in your tissues, the stability keeping you from dissolving through your seat, the optics allowing these words to reach your eyes. Thus, soliciting an explanation of magnetic repulsion via normal analogies equates to elucidating electromagnetism through electromagnetic examples. It's inherently recursive. A non-starter? Perhaps a fresh angle aids comprehension. Consider describing blue to a seeing person, gestured to the azure sky. A sapphire gem, a denim jacket, tangible instances abound. But to someone congenitally blind, you can lecture on 450 nanometer wavelengths, its spectral position flanking violet and green, the photochemistry of cone cells, all valid physics, yet none captures the subjective essence, the vivid blueness. That requires direct experience. No verbal proxy suffices. Magnets parallel this. Electromagnetism's intuition eludes superficial similes or brief overviews. Authentic grasp demands engagement. Wrestle with Maxwell's equations. Compute field strengths. Simulate interactions. Validate predictions empirically. Months or years of such immersion rewire your cognition. Formulas transition from arcane symbols to instinctive truths, not by aligning with mundane life, but by forging a novel. Mathematical mundane fields and charges become as familiar as walking. Magnets cease mystifying. They emerge as logical outcomes of charge dynamics. No bypass exists. You must invest the effort to cultivate that acuity. Still, I can proffer the mechanistic rundown. Permanent magnets arise from synchronized magnetic dipoles, microscopic magnetic vectors from electron orbital motions and intrinsic spins. A land in mass, they generate macroscopic fields. Confronting like poles elevates the system's potential energy via field interference. Thermodynamics dictates minimization of energy, hence repulsion drives separation to a lower energy configuration. That's the essence. Crave more depth. Dipoles stem from relativistic quantum effects in electron behavior, electron e-spin, courtesy of the Dirac equation, harmonizing quantum mechanics with special relativity. Why Dirac's framework? It impeccably replicates spectral lines, antimatter predictions, and myriad tests. Why these theories endure? They've withstood exhaustive scrutiny. Forecasting novelties like positrons before discovery. Endpoint. Concordance with reality. Grasp physics methodology. It shuns armchair speculation for empirical rigor. Commence with data collection, measure forces, discern regularities, formulate mathematical models, capturing them. Challenge with fresh trials. Efficacy in prophecy denotes comprehension. In physics, understanding equates not to emotional fulfillment or intuitive harmony, but to calculative prowess forecasting unobserved events. Engineering marvels. By this metric, electromagnetism is profoundly understood. QT computes electrons' magnetic moment to 11 decimals, matching experiments flawlessly. We quantify intermagnet forces forecast motions in complex setups, devise motors converting electricity to motion, generators reversing that, MRI scanners imaging internals via magnetic resonances, particle traps confining plasma, beam focusers and accelerators. This is tangible mastery, empowering dominion over nature. This perspective it lacks the cozy narrative you seek. Tough, the universe owes no such concessions. Your innate intuitions, sculpted by evolutionary pressures for hunter-gatherer survival hurling spears, foraging berries, evading beasts aren't tuned for quantum realms or subatomic electromagnetics. When science unveils intuitionifying truth's wave-particle duality, relativistic time warps, distant magnetic actions, you face a fork. Dismiss as inscrutable, demanding non-existent better accounts, or evolve your mindset. Master calculus, tackle derivations, construct equation-based paradigms over anecdotal ones. Physicists undertake this. Quantum peculiarities initially bewilder, but through persistent application, morph into familiarity, bespoke common sense, rooted in formalism. Key lesson: when next sensing magnetic repulsion, forego why, embrace how. How does intensity vary with separation? Roughly inverse cube for dipoles. How stacks against gravity, immensely superior at small ranges. How to derive, leverage Ampere-S law or vector potentials. These queries yield robust, exquisite resolutions. Yet, overlook not the splendor. Physics unveils a parsimonious universe. Magneti-scribing equations encompass lightning discharges, synaptic transmissions, semiconductor logics, auroral displays, molecular affinities, stellar fusion, atomic integrity. No explanatory shortfall. Its grand synthesis, exposing profound mathematical order amid superficial turmoil. Elementary precepts birthing boundless intricacy, that's the true marvel. Not irreducibility, but vast encompassment. You desired magnet to familiar reduction. Instead, revel. The familiar reduces to magnetic principles or electromagnetic ones, synonymous here. Furniture solidity, corporeal form, atmospheric dynamics, illumination, biochemical cascades, vitality all, electromagnetic orchestrations at varying scales. You're not a detached observer. You're an electromagnetic symphony. Declining simplistic replies isn't evasion, it's candor. Placating falsehoods impart no wisdom. Veracity honors your intellect, trusting you to embrace unvarnished reality over palliative tales. Seize those magnets anew. Savor the ethereal thrust. Recognize it as a cardinal force catalyzing reactions. Igniting sun sustaining your essence. Not arcane points. Our capacity to model it equationally, probe experimentally, innovate technologically, that's authentic comprehension. If this reshaped your worldview, hit like, share your epiphany in comments, and subscribe for further. Keep probing profoundly.